In this video, we're going to start to learn about modeling. That means when we take real life and we use math to kind of represent it. That's what modeling is. And we're going to model, focus here, modeling with slope-intercept form. Okay, so there's actually different forms of equations, which we're going to learn about later this week. Okay, but my slope-intercept form is this. Okay, and we've already learned that this B is the y-intercept when we graph, and this M is the slope when we graph. Okay, so we've already talked a little bit about slope-intercept form. Now, specifically, slope-intercept form is used to model change, right? We actually have different forms of equations, but this one is used to model change, where something, just like when we graph this, how we say, okay, I'm going to start at the y-intercept and then I'm going to figure out, okay, this slope tells me how I'm going to move. It's used to model situations where there's a starting point and then there's some sort of change. Okay, now, just like always, so if you think back to when we were trying to write equations in slope-intercept form, when we had a graph, we needed two pieces of information, the y-intercept and the slope. When we had 2 points, we needed two pieces of information, the y-intercept and the slope. Okay, so we still need two pieces of information. Now, it's actually still the y-intercept and the slope. Oh, two pieces of info. Okay, but the two pieces of information now, right, are the slope, just like always, and the y-intercept, just like always. But the question is, in a word problem, where are we going to find these pieces of information? And I will tell you, the slope and the y-intercept are going to be represented by different pieces. You're going to look in the word problem for what is the starting point? In a particular situation, what number are we starting at? So the y-intercept is the starting point. And then you're going to ask yourself, in this situation, how is something changing? And we call this the rate of change. Because when we ask how is something changing, we're talking about two things. First, like, is this number going up or is it going down? And then we say, how fast is it going up or down? Is it going up a lot? Is it going up a little bit? And that number that we can use to describe that is called the rate of change. And we're going to see it in examples right now. Okay. So we're still looking, we're going to be writing equations in slope-intercept form. We're still looking for two things, the slope and the y-intercept, okay? And you're going to see it's going to be not too different in some ways than what we've been doing. So we're actually going to do right now, I'm going to do 3 examples. So I'm going to do example number 1, example number 2, and example number 3. And then you're going to do 3 practice problems as well, okay? So just go ahead and set up your paper like this. And then you're going to write, look, I'm making a table, right? So I'm kind of making some column headings here. You're going to write starting point. That's what we're going to be looking for. You're going to write rate of change. That's the other thing we're going to be looking for. And then once we have those two pieces, we're going to be able to write the equation. Okay, so let's take a look at some examples. Example number 1. An apple tree has 20 ripe apples and 6 more ripen each day. Okay, so I'm asking myself first, what's the starting point here? Well, the starting point is that this apple tree is starting with 20 ripe apples. 6 more ripen each day. So when I'm asking what's the rate of change, I'm asking, okay, how is this, in this case, we're talking about the number of apples. How is the number of apples changing? Well, it's going up, right? And it's going up by 6. So my rate of change is positive 6. Now let's say I said, 6 are picked each day. Well, that would be negative 6, right? Or let's say 1 more ripens each day. Well, that would be positive 1, right? So it just depends on what we're given in the problem. So now when we write the equation, my rate of change is my slope. So I'm going to put that in the M position. And my starting point is my y-intercept. I'm going to put that in the B position. So I'm literally just plugging in these numbers. Y equals 6x plus 20. Okay, that's it. And this is going to help me. We're going to talk about sort of how to use this equation in a little bit, but right now we're just going to kind of take the pieces and write them. All right, let's take a look at example number 2. Mr. Gain receives $60, $60 in Starbucks gift cards for Christmas, then spends $5 a day on a handcrafted drink. Those are those fancy drinks from Starbucks. I think that's what they're called. All right, so first we ask ourselves, okay, what's the starting point? Well, let's see, the starting point is $60, right? He starts with $60. That's how much he receives. So he's at positive 60. Now, when he spends $5 per day, is he losing money or gaining money? He's losing money. So this number that he started with, it's going down. It's going down by $5 a day. So here my rate of change is -5. So when I go to write the equation, y equals -5x plus 60. Okay. And then example number 3. Ms. Broderick buys t-shirts, dyes, and rubber bands for $70. Then she makes and sells tie-dye t-shirts for $10 a piece. Okay, so I go to the store, I buy a bunch of stuff, I spend $70. So what's my starting point? Well, I just spent $70, right? I just went and I spent $70. So my starting point in terms of the amount of money I have in this particular situation, I'm starting at -70. I just spent $70, right? Now look, I'm trying to make money by selling tie-dye t-shirts, right? Now, have I made money after I bought the materials? No, I've lost money. So I'm at -70. But then every time I sell a t-shirt, right? So here I've lost money, that's negative. But then when I sell a t-shirt, now I'm starting to earn my money back. That's positive. So here I'm making $10 a piece, positive 10, right? Because every time I sell a t-shirt, I'm gaining $10. So here my equation would be y equals 10x minus 70. Okay, and you're going to go to the next slide right now, and you're going to get 3 practice problems, and you're going to try to do this same thing. Figure out what's the starting point, what's the rate of change, and what's the equation.